If you're a diesel truck fan, you probably know about the 5.9 Cummins, and you probably know about the 6.7 Cummins. But do you know about the 5-liter Cummins? While the bigger Cummins engines are used exclusively in Ram trucks, the 5-liter Cummins is actually totally opposite, and it's used in the Nissan Titan XD. Now, while it might not be as popular as the bigger Cummins engines, the 5-liter Cummins is actually a pretty cool engine with a lot of innovation and some really cool features. So sit back, relax, and get comfy, because today I'm going to tell you everything you have to know about the 5-liter Cummins. I'm going to tell you what's special about it, the innovations, the good, the bad, and everything else you need to know. To start this off, I want to clarify that there are two versions of the 5-liter Cummins. There's a commercial version of the 5-liter Cummins and the Nissan version of the 5-liter Cummins. And while they're very similar, there are some differences. So for this video, we'll mostly be focusing on the Nissan version of the 5-liter Cummins, which shares about 70% of its components with the commercial version. Although it shares a large portion of its components, it took years for Cummins and Nissan to finally bring this engine to market in their Titan XD. You might be wondering how the 5-liter Cummins ended up in Nissan's trucks, considering Cummins engines have historically been used in Ram trucks. That takes us way back to around 2009-ish, where Cummins was developing an all-new light-duty diesel that was supposed to be debuted in the Ram 1500 by 2010, but was later delayed. Chrysler's delay has no impact on the light-duty diesel engine, said Mark Land, Director of Public Relations at Cummins. We're still moving forward with the development, we're just pacing it differently. So basically, Cummins was developing an engine that they presumed would be used in Ram trucks, given their long history with supplying engines for their heavy-duty Ram trucks. But they weren't locked into that, as they publicly stated that other companies were interested in using their upcoming light-duty diesel engine. We have other customers who are interested in the engine, including Nissan. Of course, this was after Nissan had announced its partnership with Cummins, because Nissan wanted to use diesel engines in their upcoming line of light commercial vehicles that were supposed to start production in 2010. So, looping back around, Cummins was developing a light-duty diesel engine that was supposed to be used in the Ram 1500, but they were open to supplying the engine to other companies, including Nissan, who they already had a partnership with for their light commercial vehicles. Fast forward to 2013, and Nissan publicly announced that the next generation Titan would be available with the 5-liter Cummins engine. Up to this point, Cummins was still developing a version for the commercial vehicle customers. The whole goal with the Titan XD and the 5-liter Cummins was to bridge the gap between a half-ton truck and a 3/4-ton truck, because there was kind of a gap there. If you wanted a daily driver-friendly truck, you'd buy a 1500, and if you wanted a good work truck, you'd buy a 2500. But what if you wanted a 2500, so sort of a work truck, but also sort of a daily driver that didn't ride rough like a 2500 and wasn't really bad at towing like a 1500? So that's where they slotted in the Titan XD with the 5-liter Cummins. And it was supposed to be better than what the competition had to offer in the Silverado 1500, the Tundra, the F-150. It was supposed to offer better performance than all of those, while still providing better daily drivability and ride quality compared to a 2500 truck. Although there's that big gap in the market and the light-duty trucks were supposed to fill it, that market ended up not being quite as big as Nissan had expected, but more on that later. That loops us back around to the original question. Why didn't Ram use this engine in their 1500 trucks? And the answer is actually really simple. It's just fuel economy. According to Ram, their research showed them that customers expected superb fuel economy from a 1500 diesel truck. So rather than going with the 5-liter Cummins, they opted to develop their own engine with Fiat's VM Motori, which was the eco-diesel engine. This video isn't about the eco-diesel, so we're not going to get into that. But basically, they developed the eco-diesel because they wanted more fuel economy than what the 5-liter Cummins was going to deliver. Now that you have an idea of why this engine ended up in Nissan trucks instead of Ram trucks, let's take a look at the engine itself and what makes it such an interesting platform. What makes the 5-liter Cummins so different from Cummins engines that you'll find in other pickup trucks is the fact that it's a V8, where the 5.9 and the 6.7 Cummins are both inline-6 engines. Despite having a vastly different configuration than the Ram's Cummins engines, it features many of the same design characteristics. Most notably, it features a compacted graphite iron block, or CGI for short, which is the same durable and relatively lightweight block material used on the 5th-gen Cummins-powered trucks. For the engine to be lightweight compared to other diesel engines, everything had to go on a big diet. Now, that's part of the reason that this engine uses a CGI block as well as aluminum cylinder heads. The overall thickness of the block was also optimized for this application because the target power is much lower than the bigger diesel engines such as the 6.7 Cummins. On top of the focus on weight, this engine was designed to be similar in its physical size to a gas V8 engine, which made it much easier to fit into 1500 applications like the Titan. All of that adds up to an engine that weighs around 900 pounds when dry, which is fairly lightweight for a diesel engine. On top of the weight saving benefits, this engine features thick composite valve covers, which help to contain some of the noise. You have to remember that this engine was designed for half-ton trucks, which see a lot less work-related use and a lot more daily driving. So overall noise, vibration, and efficiency were really important to a Nissan. Something that I found very interesting is that Cummins decided to give this engine 4 head bolts per cylinder, which, as you might know, is something that Navistar did on the 6-liter Power Stroke, and that ended up being a complete disaster. With that said though, the 5-liter Cummins does not seem to have any of the same issues that plagued the 6-liter. Inside the engine, you'll find cast aluminum pistons with piston oil squirters beneath them to help keep them cool. Bore and stroke measure at 94 millimeters by 90 millimeters respectively, with a compression ratio of 16.3 to 1 to top it off. Ceramic glow plugs supplied by Bosch are designed for quick start times and to last the lifetime of the engine without any maintenance. The ceramic glow plugs also help improve emissions on cold starts. In terms of the injection system, we're looking at a system supplied from Bosch. Starting at the pump, it's a CP4.2 pump, which is the same injection pump that you'll find on the 6.7 Cummins and the LML Duramax. The injection pump is supplied with fuel from a chassis-mounted electric lift pump. Those two combined supply the common rail injection system with around 29,000 psi of injection pressure. While the new fuel injection systems used on modern diesels are very capable and efficient, the CP4.2 pump is well known for being very sensitive to fuel quality. To help protect the entire fuel system, an advanced Cummins 2-stage filtration system is used, which provides significantly better fuel filtration by using the latest NanoNet media from Cummins Filtration. The NanoNet filter media reduces flow restrictions while simultaneously trapping more than 99% of all particles as small as 4 microns. Even with that though, the CP4.2 pump is a dangerous failing point. If the pump self-destructs, it'll send metal fragments through the lines and rails, into the injectors, and then out the return system. Detecting this failure before it happens is basically impossible, and by the time it's through, you'll need to replace the pump, the lines, rails, injectors, and more. It gets really expensive really fast, but it kind of makes sense in this context because the Bosch CP4.2 pump is one of the more popular pumps used on common rail diesel engines. You'll find it on other diesels such as Power Stroke, Cummins. It's just a little unfortunate to see it used in this application because there are more reliable pumps available on the market. All of that is topped off with piezoelectric injectors that can fire up to 7 times per combustion event. One of the big benefits of piezo injectors is how quiet they are, which again is something that Cummins and Nissan wanted to focus on to help improve the drivability with the Titan XD. That brings us to the turbocharger, which is one of the more interesting parts of the 5-liter Cummins. The system comes from Holset, and it's known as the M2 dual stage turbo. This is simply a twin sequential system that uses 1 small turbo and 1 big turbo. This design provides excellent performance throughout the entire power band. The smaller turbocharger is used to provide quick throttle response and acceleration, and adequate performance for lower airflow scenarios. The larger turbocharger provides better performance at higher engine speeds or under heavy loads. What blows my mind is the fact that they fit this 2 turbo system, so you got this whole big thing. They fit it in the V of the engine underneath the intake manifold. Helping the 2 turbos work together, it has an electronically actuated wastegate system with a patented rotary turbine control valve that operates the opening of ports during 4 main operation modes: the low pressure single stage turbo mode, high pressure 2-stage turbo mode, wastegate mode, which is basically just maximum engine power output, and a regeneration mode. What's a little strange is that some of the earlier reports before the Titan XD launched stated that the engine would be using a variable geometry turbocharger setup, but this system isn't variable geometry at all. In fact, part of the reason they developed this entire system was to have a viable alternative to a variable geometry turbocharger. Jonathan Wood, Executive Director, Research and Engineering, said, "Advances in air handling technology and improved system integration continue to provide new turbocharging solutions that enable customers to achieve their emissions and efficiency targets without compromising engine performance. Highly efficient and highly durable, This pioneering technology offers a smart alternative to variable geometry. Nissan is the first to benefit from this new technology. Working in partnership with Cummins Engines team and Nissan, we have developed a custom system solution which is tailored to their customers' operational requirements. While this turbocharger system is unique, interesting, and very efficient, it can be a little problematic. More specifically, around 12,000 Titan XDs were recalled for turbocharger lubrication issues. Due to a manufacturing defect, low oil pressure would result in the turbo being starved of lubrication. This would cause the turbine wheel to come in contact with the turbo housing, and when this happens, metal shavings are sent through the turbo and into the engine, potentially leading to catastrophic engine failure. All of this equals out to a pretty decent performance for a relatively small diesel truck engine at 310 horsepower and 555 pound-feet of torque in the Titan XD. Strangely enough, on the Cummins website, if you look at the 5.0 ISV, which is the commercial version of this engine, it actually has a lower horsepower rating than the Titan XD version of this engine. So Nissan definitely asked them to crank it up for this application. That being said, the 310 horsepower figure might actually be a little bit underrated, with some Titan XDs putting around 280 wheel horsepower down on the dyno. So either this engine is underrated or the A466ND transmission is just really good and efficient. All of that loops us around to the part of diesel engines that everyone loves to hate, and that's the emission systems. On the bright side, the advanced emission systems combined with the advanced turbo leaves the 5-liter Cummins with impressively low emissions output, but those same emission systems are also the biggest failing points on the 5-liter Cummins. It features all the systems you're familiar with on modern common rail injection system diesels, which is a diesel particulate filter, exhaust gas recirculation system, and a selective catalyst reduction system with diesel exhaust fluid injection. We've covered diesel particulate filters in other videos, but to briefly recap, the job of the DPF is simple. Capture excessive exhaust soot and then burn it off occasionally through a regeneration mode. It does the regeneration through two modes: an active regeneration mode and a passive regeneration mode. The EGR system is used to lower combustion temperatures by basically diluting the air-fuel mixture with a small amount of exhaust gas, and that's paired with an EGR cooler, which cools the exhaust gases before they enter back into the intake. And last but not least, the SCR system works to reduce emissions by spraying diesel exhaust fluid into the exhaust system, where it is converted to ammonia, which then breaks down nitrogen oxide into nitrogen and water. Unfortunately, all those emission systems have some issues. Most notably, the DEF system has issues with the DEF pump failing, which is most often caused by contaminants getting into the pump. If this pump fails, it can put your truck into a limp mode, and if left untreated, can create even more issues. On top of that, the EGR coolers are known for failing, and the EGR valves are known for sticking. The EGR valve gets stuck open or closed from carbon or soot buildup. So in terms of performance, you can see around 400 to 450 horsepower and upwards of 700 pound-feet of torque on the 5-liter Cummins when it is tuned and deleted, which isn't particularly good when compared to the larger engines such as the 5.9 Cummins or the 6.7 Cummins especially, but it kind of makes sense in this context, because you have to remember this engine was mostly designed for quiet operation and great fuel economy. It wasn't necessarily designed to make a huge amount of power. So you have a relatively restrictive turbocharger system and a relatively small displacement of only 5 liters. When you put it that way, 400 to 450 horsepower and 700 pound-feet of torque, it's actually not that bad. If you were to swap that OEM turbo system out for something more aggressive like a single turbo, you can see upwards of 550 wheel horsepower and 900 pound-feet of torque, and that's definitely not half bad. But a similarly modded diesel like a 6.7 Cummins or even an LBZ Duramax or an L5P or a 6.7 Power Stroke, if you were to upgrade one of those with a large single turbocharger, they're going to blow the doors off of the 5-liter Cummins. But again, it makes sense. The 5-liter Cummins is smaller and it was designed for fuel efficiency. It's not designed for big power like those larger engines are. So that's about everything you need to know about these 5-liter Cummins used in the Titan XD. I want to know what you guys think though. Do you love this engine? Do you hate this engine? Do you think Nissan could have kept using this engine? They dropped it after a very short stint. The Titan XD was not around for very long, and currently the 5-liter Cummins is not being used in any applications other than commercial applications. Let me know down in the comments below. While you're down there, get subscribed so you don't miss out on future videos. Check out the other videos on the channel. We have a ton of videos. You'll probably love them, and I'll see you guys in the next one.